So far we looked at calculations with strong acids. Now let's take a look at what happens when we have a weak acid. So it's important to remember that a weak acid is at an equilibrium. So it has an equilibrium constant. So the K equation. The K equation for an acid is going to be the same as we do for any other K value, which is involves the concentrations of our products over a concentration of our reactants. If we look at the reaction of CH3COOH plus water, going to CH3COO minus plus H3O plus, AQ, this is AQ, this is AQ, and this is a liquid. We can come up with this K equation, which is our products, so concentration of CH3COO minus, concentration of H3O plus, divided by the concentration of our CH3COOH. Remember that since water is a liquid, we leave it out of our K equation because we leave our liquids and solids out of our equilibrium expression. The Ka for this particular equilibrium is 1.8 times 10 to the negative 5th. So we're going to walk through how would we find the pH for this weak acid. So it's going to be a bit more complicated than we did for strong acids. So first, we're going to need to remember our pH. The pH is equal to the negative log of concentration of H3O plus. So first, we're going to need to find the concentration of our hydronium, or H3O plus. So in our reaction, we want to find the pH of 2.00 molar CH3COOH, so the acetic acid. We know the K value and the K expression. We looked at that in the previous slide. So the K value is 1.8 times 10 to the negative 5th. This is a value you would have to be given or be given enough information to calculate, so you wouldn't be expected to memorize them. So let's look back at this balanced equation. So we have it at equilibrium. Now, we know we want to find our H3O plus, right? We know the CH3COOH, so this is given, but we don't know the CH3COO minus, the acetate ion concentration. So we're going to have to kind of make a little bit of an assumption here. And that is that with 2.00 molar CH3COOH, we initially start with a concentration of 2.00 molar CH3COOH. And some of that is going to react. We're going to call that X. Because this is has a coefficient of 1, for every one of the acetic acid that reacts, we're going to get one acetate and one hydronium, because that's the coefficients in our balanced equation. So that means we're going to subtract X here, we're going to add X here and here. We're going to assume that X here is very low, so we're not going to worry about it here for our calculation. But essentially what we're going to say is that our concentration of CH3COOH is going to be equal to 2.00 molar that we're going to use in our equation. The concentration of CH3COO minus is going to be equal to X, and the concentration of H3O plus is going to be equal to X. So this is a simplification because normally this would be 2.00 molar minus X, but we are going to assume that this X is very small. So it's not going to affect our initial concentration that much. This is a assumption that we make with these types of calculations. So I'm going to plug my X's and these concentrations into my equation. So I have my equilibrium expression. I substituted X for CH3CO minus and H3O plus and 2.00 molar. I'm going to solve this equation for X. So X times X is going to give me X squared. I'm going to rearrange the equation, so I'm going to multiply both sides by 2.00 molar so that the 2.00 molar is going to be eliminated. So I get that X squared is equal to 3.6 times 10 to the negative fifth. Now we reverse a square by taking the square root. So I take the square root of both sides, and I get that X is equal to 0.0060 molar. Now remember that X is equal to our H3O plus, so our concentration of H3O plus is equal to 0.0060 molar. Now that I have this concentration, I can put it into my pH equation. And solve for pH. So pH is equal to the negative log of H3O plus. Negative log of 0.0060 is equal to 2.2. So the pH of this solution would be 2.2. It is a bit more complicated than doing the strong acid calculations, but as long as you're careful and make sure and go through all the steps methodically, make sure you understand how to put your log into the calculator, how you do your exponents and square roots, then you should be able to get your pH. Remember, always double check, is your pH somewhere between 1 and 14? Most pHs are somewhere in this range. Sometimes they go slightly lower or slightly higher, but if you get something that's wildly outside that range, do make sure and double check your calculation.